right, you're gonna start graphing the trig functions. We're gonna start with sine, basic sine function. There's no transformations, there's no vertical lift, there's no phase shift, there's no amplitude change, nothing. All this will make sense to you guys later. You guys learned parabolas with all of that. You'll learn this as well, okay? So we're going to start with number 3 first, because if you notice that x-axis is in radians, pi over 2, pi, right? 2 pi, 3 pi over 4. So we're starting with this one first. All right, the amplitude is 1 because obviously the A is your amplitude. It's there. It's 1. There's no phase shift. There's no vertical shift. There's no any of that, okay? We're going to use the chart. So I'll use this little small pink one. But before that, we're going to go over your quadrantal angles, your 0, 90, 180, 270, 360, and then, you know, keep going around and around and around. Don't wait for this. I'll wait for you to copy. Okay. Because I'm going to put another sheet underneath. I know it's a weird A. It was supposed to be a capital A equal 1 amplitude. I know the pen like bled. It closed. This is a capital A. It's just the pen kind of bled right there and closed up my capital. It's that one right there. Okay, so all right, so look, quadrantal angles. Look, you guys have a unit circle that goes in a circle. That's a unit circle. I know that's a terrible circle. Okay, on a traditional, very basic sine, cosine, tangent, all of the functions where we haven't, like the parent graph, like with parabolas, we haven't shifted them in any way. We haven't transformed them in any way. Your high and low is 1. So your radius is always 1. So as it goes around the circle, right, and it revolves, so at 0 degrees, this radius is then 1. Here it's 1, 1, 1 as it moves around. Okay, so when you're talking about your quadrantal angles, no Pythagorean theorem necessary. If 0 degrees is here, then that means the radius, it would then be a horizontal line. And so this location is 1, 0, right? X, Y. So in this case, cosine is 1 and sine is 0, because that point would be 1, 0. And so that's why when you look here at 0, you see cosine is 1 and sine is 0. And then tangent, right, is sine over cosine, so what's 0 over 1? 0. Okay? All right. So now as the radius moves vertically upward, this location, this point here is 0, 1. X is 0, but then it rises 1, and so cosine is 0, sine is 1. And so that's why on the 90 degrees, sine is 1, cosine is 0. Why is it undefined? Remember, it's tangent is sine over cosine. 1 divided by 0 is undefined. You can't divide by 0. We'll go through this because we're going to have to graph it, so we'll go through it as well. Okay, look at 180. 180 is 0, negative 1, 0. Okay, why is that? When the radius moves and it comes here, it's a horizontal line, right, or segment, facing the left, and so this location dot here is negative 1, 0. But remember, it's always cosine, sine, like alphabetical, like X, Y. If you ever forget and you always want to go sine, cosine, it makes sense because that's how your chart is labeled. But remember, it's always alphabetical, cosine, sine. And so then when the radii drops south, that location is 0, negative 1. And so that's why then on 270, you have negative 1, 0, and that's where your 1s are coming from. It's because on a very standard trig function, your radius is 1, and then all it does is spin around. That's it. So let me just stop it here.
Yeah.
Because then we're